what we're going to do is we're going to compare what happens when you go from your original function, in this case is the absolute value of x, to the graph of y equals 1/4 absolute value of 2 bracket x plus 3 absolute value plus 4. And what we're going to find out is that when we have multiple transformations like this, first of all, you'll probably label things. So underneath here, can you see that this 1/4 is outside the absolute values? So it's going to be a vertical compression. You would multiply your y values by 1/4. Then inside the absolute values, we run into the 2. That's going to be a horizontal compression. You're going to multiply your x values, not by 2, but by 1/2. Is the plus 3 inside the absolute values or outside? Inside. So that plus 3 is going to be a horizontal translation. It would move 3 to the left. And finally, the plus 4 is outside. That will be a vertical translation, 4 up. So as a special note off to the side, when there are multiple transformations, in this case we have 4 of them, maybe I'll use the word perform. The order is important. Perform your transformations just like you would read them from left to right. In other words, stretches and compressions first, and then we'll do the translations second. Now, sometimes you'll see someone do a question like this, and they'll do one at a time. And that's sort of what the textbook set it up as. Said, can you do just this one? And then can you add this one? And then can you add this one? And then add this one. And we could graph like 6 or 7 different graphs. And if you do all your graphs on the same graph, it gets really confusing. So instead, we're going to just do this all at once and go directly from the graph that we started with to the graph that we want to get. So one of the things that you're always going to do first is you're going to have a picture of your original graph. So do you know what the absolute value of x looks like? Yes. It looks like that. What are some of the key points on the absolute value graph? Well, this one's the most important, 0, 0. Then you have other points, 1, 1, 2, 2, 3, 3, 4, 4. Probably in this situation, because I've already written in green what's going to happen, I would probably choose 4, 4, and negative 4, 4. Why are those good points? Because I know that I'm going to have to multiply my y values by 1/4. And can you see that 4 multiplies by 1/4 nicely? It's not that the other points are wrong. They just might end up with more fractions. So what we do, right, when multiple transformations, perform your transformations from left to right, do your stretches and compressions first, and then your other translations. What does that look like? Well, you take the points that you had on your original graph. So we took 0, 0 is an important one. We had 4, 4, and we had -4, 4. You'll have one set of arrows for all your stretches and compressions, and you'll find out where the new points are. Then you'll have another set of arrows for your translations, and we'll find out where our new points are. So as far as looking under our equation, okay, and I'm going to label this, okay, stretches, and here translations. We do our stretches and compressions first, then our translations second. Are you okay if I just write stretches and don't write compressions? Because really, in this one, we just have compressions. I probably should have just wrote compressions, but it's okay. So what do we write above our stretches? How many stretches do we have, or compressions? We have 2 of them. So above, or in this section, I'm going to write that I need to multiply my y values by 1/4, and I need to multiply my x values by 1/2. If we do that with these 3 points, x values by half, 0, 2, -2. Y values by 1/4, 0, 1, 1. Find out where the new points end up. Next, we do our translations. So above the second set of arrows, I'm going to say we need to go 3 to the left and 4 up. What's going to happen to our points? If I'm at 0 for my x, 3 to the left will take me to -3. -1, -5. 4 up will take me to 4, will take me to 5, will take me to 5. I can now put my axes on my graph and say I'm going to have a point at -3, 4. I'm going to have a point at -5, 5. And a point at -1, 5. And I now have enough information to draw my graph. Oops. Did anybody see what I did when I labeled it? My 5 went up a little bit too high, didn't it? Oh. And I didn't even catch it when I labeled it. Okay, hopefully you graphed it correct on yours because you actually labeled the points in the right spot. -1, 5 would be there. -5, 5 would be there. That looks similar, but a little bit labeled a little bit better. So what ended up happening? It got squished, then moved 3 to the left and 4 up. And this would be the final graph. And the graph, what we just did is we just graphed this really crazy looking equation, and it wasn't that bad. The way that we did it is we took points from our original graph, 3 of them, set up a diagram showing how those points are going to change by doing stretches and compressions first, and then translations, and then we could plot our final points and draw our graph. Again, as a check, you could think about what would happen to this blue square root graph if I squished it down, then squished it horizontally, then moved it 3 to the left and 4 up. Does my final graph seem reasonable? Yes, it does. So let's go to example 1. Here's the graph of g of x. Sketch and label its image after vertical compression by a factor of 1/3, and then a translation 2 units up. So for this one, it's a weird looking graph with a bunch of straight lines. Can you see there's 4 key points? We can take those 4 key points. One of them is at -5, 3. Then -2, -3. 1, 0. And finally 4, 6. We set up a set of arrows for stretches and then a set of arrows for translations. The question tells us for our stretches, we only have 1 stretch or compression. It's a vertical compression by a factor of 1/3. So above the first arrow, you will say, I'm going to have to multiply my y values by 1/3. Followed by a translation of 2 units up. That's in our second. We do translation second, 2 units up. So the only thing being affected here is your y values. First, they're getting multiplied by 1/3. So your x values don't change. Y values by 1/3. And then your y values get shifted 2 up. So again, your x values don't change. Add 2 to each of your y values. And plot your new points. We'll have a point at -5, 3, -2, 1, 1, 2, and 4, 4. Connect your lines, and there's our final graph. Can you imagine this one being compressed towards the x-axis and then shifted up 2 units? Does it seem to be about the right shape? Yes, it does. If we were going to write the equation of the blue graph in terms of g. So I'm doing this more often because this is the language that comes up on your exam. Could I write the equation of my blue graph in terms of g, and g is my red graph? Well, what's happened? If I want y to be compressed by 1/3, that 1/3 would be outside of my function. And if I want to have it shifted up to, that +2 would be outside of my function. So the equation of g of x would be y equals 1/3 g of x plus 2. Now in this situation, we're also going to go over the example that the textbook has off to the side, just regular example 1, because something happens in this one that's important to look at. Okay? The beginning part of this question is exactly the same as the one that we just did. It's going to be easy. You want to do a horizontal compression by a half and a translation 3 units left. So nothing's different. Our points, we're going to start off with -4, 4. We have 0, -2, 2, 5, and 4, 2. You set up your arrows the same way. We have our stretches and compressions first, followed by our translations. And above, horizontal compression by a half means that you would multiply x by a half. So whenever the language in a question for horizontal stretches and compressions, if they say compressed by a factor of a half, that means your x value gets multiplied by a half, exactly as they say. It's only in the equation, which we're going to do after, that that would show up as a 2.
Would the first one be -4, 3?
Is it -4, 3? Yes, thank you. And then it gets translated 3 units to the left. So we have 3 units to the left. I would like to say that I wrote -4, 4 just to see if you were paying attention, but that is not true. I just labeled it wrong because that was super easy to label a point, so I stopped paying attention for a half a second and made an easy mistake. This is going to happen to you many times. And when you check your answer at the back of the book and you get it wrong, you're going to be frustrated. It's okay. You know what you're doing, but sometimes you just make those silly mistakes. So now what's going to happen? Well, our x coordinates are what are changing. Our y coordinates stay the same in this case. So nothing's really different so far. By a half, -2, this would still be 0. This would be 1. This would be 2. And then 3 to the left, again, our y values don't change. I'm going to subtract 3, so it's going to get to -5, -3, -2, and -1. We can plot those points, -5, 3, -3, 2, -2, 5, and -1, 2. Connect your points. Take a look. Does it look like it's been compressed? Uh-oh. What did I do wrong? Yeah, I forgot. My labeling went bad. Okay, -5, 3. That one was good. -3, -2. I totally forgot that negative. That should be down here. Okay, -2, 5. That one was okay. And -1, 2. That one was okay, but I had this bottom point was wrong. And when did I notice it? Is when I did that mental check. Does it look like it's been compressed by a half and moved to the left? I was like, no, it also looked like it got moved up or something. Something seemed to be wrong. So then I had to do a check to see which point did I possibly label wrong. And again, that would be a perfect example of doing a mistake on purpose. But I have to admit that that was just a mistake. And so we have our final graph. Now the reason I wanted to do this one, because right now you're saying, Mr. JR, this is identical to the one you just did. It seems a little bit redundant. Yes. But where this one is different is in the notation. Okay? If you were asked to write the blue equation in terms of f, should I write it? I'm going to write it in 2 ways. One way is going to be correct, one way is going to be wrong. You have to decide which one you think is correct and which one you think is wrong. Don't write any down unless you want to put a big X through one of them. Okay? Here's the idea. We have y equals, in terms of f, everything is going to be inside of the function. We have to multiply by 2 or we multiply by half, that shows up as 2 inside the function. And then we need to go 3 to the left, so that will show up as plus 3. Or should I write it without those extra brackets? Y equals f, multiply by 2, and then 3 to the left, like that. Can you see why those two are different? If I simplified the first one, it would be 2x plus 6, right? If I distributed. And the second one is 2x plus 3. So they're different. One of them is right. One of them is wrong. Okay? It doesn't matter if you're right or wrong. I just want to know what your initial gut feeling would be. If you want the one on the right, raise your right hand. If you want the one on the left, raise your left hand. Go with your gut. So everybody has a gut, so you have to put one hand up whether you're right or wrong. What do you think it should be? I need to do a consensus. You have to put a hand up, right? If you have no idea, put one up at random. Okay, all right. Okay, so, see, it's exciting. It's like a suspense movie almost, right? You just can't, now I can't wait to find out what's happening in math. It's so exciting. Should I write the note, special note first, or you want to know the answer right away? Okay, okay, this one's, sorry, that one's bad, right? Everything inside the function goes against what your gut feels, and that one was just too simple looking, so it's wrong. And that's the one most of you thought, so. Okay, why? What happens? Special note, write this at the bottom of the page. Special note. Oh, I have stuff to tell you about this special note. Special note. When you have and I'll put capital letters, horizontal stretch, and this time I'll write them all out, compression, or even a horizontal reflection. And a horizontal, big capital letters again, translation. You, capital letters, different color, must write it in factored form. If you were paying super attention from the beginning of class, there was one hint why the one on the left was the right one. The hint was when we started the very first question. If you look at the very first question that we dealt with, see how it was in factored form? That was really hidden, though. It'd be hard to remember that. So in this one, it was written in factored form, and then your translation was 3 to the left. If I distributed that, I would have a plus 6. This is the #1 special note that people forget. Okay? It is hard to remember. You'll see this and want to go 3 to the left, whereas this one that's X'd out is really only 1.5 to the left. I had one student one year who said, I'm not going to forget these things, all the important things you tell me all year, Mr. JR. She put into the calendar of her phone, 10 p.m. every night, her phone sent a reminder. And the reminder said, special note, when you have a horizontal stretch, compression, reflection, and a horizontal translation, you must write it in factored form. I mean, by the end of the year, she had so many reminders, like, oh my goodness, it's 10 o'clock, beep, 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 beep. All the important things that she needed to remember, although it did help remember some of those things. Oh wait, questions for practice for #1 are 4, 5, and 6.